Hey guys, welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So I'll be continuing the previous tutorial, and if you have not seen the previous tutorial, then there's no meaning in going ahead and watching this, because if you have not seen previously, then everything over here will go bouncer for you. So I'll just go through previously. As mentioned previously, the framework will choose the best encoder possible when generating our payload. But there are times when one needs to use a specific type, and regardless of what Metasploit thinks. So if you use a non-alphanumeric characters or some stuff or some command that contains only non-alphanumeric characters, the Shikata-Ganai encoder would not be appropriate in this case, as it uses very much every characters available to encode. So looking at the encoder list, I will go ahead and use the non-alpha encoder or into 32-bit non-alpha encoder that would be present. So I'll just go ahead and try to see what things are available. So I'll just type show and I'll just type encoders. As you can see, we have these multiple payloads, but over here I would not be using them. I want something which does not contain alphanumeric characters. So let's see if we have that. Into 86 and let's see. Okay, so as you can see, we have the 32-bit non-alphanumeric character. It is quite low, it's not that good, but again, it's not about having the good one. Sometimes it's about actually going ahead and getting out of that. And whereas Shikata-Ganai was an excellent one, we will be using the lowest one, which is not that good. But still, it will prove to be excellent, and I'll show you how. So let's go ahead and generate a non-alphanumeric character payload. So I'll just type generate /e space into 86 / and I'll just type non alpha. Okay, no encoders. Encoded the buffer successfully. Okay, I'll just go ahead and check. Okay, perfect. So let's redo our bind shell payload, but this time we'll tell the framework to use a non-alpha encoder, and I'll be using the e switch hyphen e switch over here. So previously it was not that good and it did not run in a perfect way. The reason being that I used that and it was a non-alpha encoder. But let me check if I could go and do that again. So if everything went according to what I said, our payload will not contain any alphanumeric characters. But we must be careful when we are, let's say, we're using a different encoder other than the default, as it tends to give us larger payload. For instance, this one is much larger than our previous examples. So let's go ahead and check what exactly. So okay, so -e to go ahead and use the name of the encoder for E, and I'll just use into 86. Cannot see any reason why it is not using the tab completion. 6. Let me check if I could go and get more help. Okay, I'll just go and show encoders, and I'll be using the non-alpha. So I'll just copy it and paste it over here. Okay, perfect. So what was the mistake that I did previously? Let me check. Non-alpha. Okay, non-alpha into 86 non-alpha. Okay, I cannot see any. Okay, it was the spelling APLHA. My bad. Never mind. So our next option would be on the list would be the -f switch, and I'll just go ahead and show you exactly the generate help. -f is the output file name, so it's not a big deal. This gives us the ability to generate our payloads to a file instead of displaying it on screen. So as always, it follows the generate command with the file path. So you can just go ahead and type in the generate as just to show you -f, and you can just type root and wherever you want to go ahead and save it to, and the file name in the end. After that, we have the -b command, which is the list of characters to avoid that I have already taught you. And this is not exactly what I would be teaching you right now, because by using the cat command, that's the same way we would be using the command shell. We can see our payload was successfully saved. So as you can see it, it's also possible to use more than one option when generating a payload. So I just don't want to use the B. I can use the encoders, the characters to avoid, and the -f to go ahead and use the same thing. So the next one on our list of option is the iteration switch, that would be -I. That's the number of encoding iterations. That would be in a nutshell. This tells the framework how many encoding it passes it must do before producing the final payload. One reason for doing this would be to create a stealth and antivirus evasion. Antivirus evasion is covered in greater detail in one of my later tutorials. So let's compare our bind shell payload generated using one iteration versus two iteration on the same shell code. So I can just go ahead and do the same thing again, generate -b, and I can just go ahead and type /00/ and I can hit enter, and then I can just go ahead and type the same thing plus -I and 2. So it will be encoded twice. So comparing the two outputs, you can see the obvious effect that the second one was 382 bytes and the previous one was 355 bytes. And the second one is quite a big and it's much better. So if you go and compare the two, the effect, you can see the obvious effect that second iteration had on our payload. First of all, the byte size is larger. The more iterations one does, the larger our payload will be. Secondly, comparing the first few bytes of the highlighted code, you can also see they are no longer the same. This is due to the second iteration or second encoding pass. It encoded our payload once, then took the payload and encoded it again. So let's go ahead and look at our shell code and see how much of a difference 5 iterations would make. Just type 5 and okay, it's 463 bytes. Not that big, but again, sometimes it depends a lot. So the change is significant when compared to all the previous output. It's slightly larger and our bytes are nowhere near similar, which would in theory make this version of our payload less prone to detection. I have spent lots of time generating shellcode from the start with default values. So in case of a bind shell, the default listening port would be 4444, that as you can see over here, and the RFOD and everything else we would have to provide. Often this must be changed. So you can accomplish this by using the -O switch followed by the value that you wish to change. Let's take a look at which options we can change for this payload. From MSF console, I'll issue the show options command, and as you can see, we have the L port as 4444. So I can just go ahead and type L port and I can just type, let's say 445. So if I go ahead and check the show options, and as you can see, our L port has been changed to 445. So we can go ahead and change it to anything that you want. And the syntax is variable equals to value. That's it, nothing much. So it can be separated by a comma in between, so not much that way. After that, we have the generate -O command, and the L port. I can straight away go ahead and type, let's say, if I want to do multiple things at one time, -O, and I can type L port equals to 1 2 3 4, and I can type comma, and I can type, let's say, exit function equals to SEH to go ahead and securely exit -B slash, and I can just type x00, and I need to go ahead and put this in quotes, then 0, and I can just go ahead and encode it using the into 86 slash shikata underscore g underscore 9, and as you can see, it's again 355 bytes. The reason being that I have not ran it multiple times, but still it's good, and our port has been changed to 1 2 3 4, and yeah, that's it. You cannot see any x into 00 or anything other thing. So finally, let's take a look at the NOP, sled length, and the output format options. When generating payloads, the default output format given is Ruby. Although the Ruby language is extremely powerful and popular, not everyone codes in it. And we have the capacity to tell the framework to give our payload in different coding formats such as Perl, C, or Java, for example. So adding a NOP sled at the beginning is also possible when generating our shell code. First, let's take a look at few different output formats and see how the -T switch is used. Like all the other options, all that needs to be done, it is a type in the switch followed by the format name as displayed in the help menu. So I can just type generate -T C, and it will be encoded in C again, and you won't see much of a difference over here. If I wanted it to encode in Java, then I can just type JAVA, and it will be encoded in Java. As you can see, the difference is quite huge, but the size is the same. Never mind. So looking at the output for the different programming languages, you can see that each output adheres to the respective language syntax. A hash is used for comments in Ruby, but in C it's replaced with slash and asterisk, such as this and this. And that's the syntax. And looking at all the three outputs, the arrays are properly declared for the language format selected, making it ready to be copied and pasted into our script. So also adding NOP, that's no operation or next operation sled. It is accomplished with the -s switch followed by the number of NOPs. This will add the sled at the beginning of our payload, and keep in mind that the larger the sled, the larger the shellcode will be. So adding a 10 NOPs will add 10 bytes to the total size. And so I'll just go ahead and show it to you. Generate -s and 14. And you can see that it's 342 bytes in between, and it just added the 10 bytes. It was 335 or something like that, and it increased. So this highlights the yellow text shows us that the NOP sled at the payload's beginning, and comparing the next three lines with the shellcode, you will be able to see that they're exactly the same. Total bytes, as expected, grew by 14 bytes in total, from 330 to its 342. Sorry, 328 to its 342. So yeah, that would be it for this tutorial, and that's much for payloads. It's there's nothing much to that. So you can just go ahead and check every payload and see how they are encoded and get much more information to that. So that would be it for this tutorial, and in the next tutorial I'll be starting with the database of the MSF exploit, or sorry, not MSF exploit, of the MSF console, that's the Metasploit, and we'll get into much deeper database and how we can create our own database in that itself.